In this video, we will consider something very essential for physics, namely units. Without units, we would just have meaningless numbers, only math and no meaningful physics. Suppose you are conducting a survey where participants have to report their height. They will probably answer something like 150, but the number itself is meaningless. 150 what? Bananas. We need units to make numbers meaningful, so in this case we would possibly require answers to be in centimeters. In this video we will discuss units, and to keep things simple, let's start with SI units. The SI units are based on 7 fundamental units or base units, and from these units you can derive all other SI units. So let's start going through the fundamental units. First we have the meter, which abbreviation is just m, and this unit is used to measure length. The next unit is the kilogram, or in short kg, which measures mass. Then we have the second, or in short s, which is used to measure time. These three are possibly the most well-known and most used units. And a lot of the units we would need for everyday life can be derived from just these three units. Moving on to the fourth fundamental unit, we find the ampere, or in short, capital A. This is the unit to measure electrical current. Next we have the Kelvin, or in short, capital K. This is the SI unit for temperature, and it's not Celsius. Then we have the mole, or mole, MOL, which is very important in chemistry, and it's used to measure amount of substance. Finally, we have the last unit, candela, or in short CD. This unit most people never really use, but it's used to measure luminous intensity. Usually the unit lumen is used when discussing light, but this unit is actually derived from candela. Now that we have covered the fundamental units, we can discuss some of the most well-known derived units. By combining units, we can form new units. For example, dividing meters with seconds yields the unit velocity or speed, namely meters per second. Likewise, we can define an area by squaring the unit of length. Thus, we obtain the unit m squared. Such units are called derived units, and there are a very long list of such units, so I will just mention a few. A more complicated derived unit would be the unit for force called Newton, and in this case we must combine both meters, kilograms and seconds to obtain the unit kilograms meters per second squared. When solving equations, it's easy to make a mistake and then your result will be wrong. A very important tool for any physicist is something called dimensional analysis. Units are often referred to as the dimension of some quantity, so dimensional analysis is simply where you check that the unit makes sense. As a simple example, consider Newton's second law, F equals to ma, and look at the units. We see that the force F can be written in terms of the base units kilograms meters per second squared. According to dimensional analysis, we must have the same units on the other side of the equal sign. We see that the mass m just has the unit kg, and the acceleration has the units m over second squared. And combining these units gives us exactly the units of force. So a good way to check that your work in physics is correct is to make sure that your units make sense in your result. Otherwise, you probably made a mistake. If the units are correct, you might still be wrong, but then the error is not in the units. Earlier I mentioned that both speed and velocity have the same units. Many people probably use these words interchangeably, and while these units quantity are very similar, they are not the same. The difference is that speed is a scalar, but velocity is a vector. Now you might ask, what is a scalar and a vector? The simple explanation is that a scalar is just a number, A vector, on the other hand, is a number with a direction. For example, if you're driving at a constant 20 kilometers per hour and turn left, then your speed will be the same, just 20 kilometers per hour. The velocity, however, is different because now you're going in a different direction. Thus, velocity carries more information than just the speed. The fundamental units are all scalars, but there exist many derived units which are vectors such as acceleration and force. When discussing vector units, we often neglect the directional part and just consider the absolute value. Finally, I will just mention that there also exists something called tensors, which are even more complicated objects than vectors, but we will just skip that discussion for now. A nice thing about SI units is that they are metric, which means that it's base 10. This simply means that, for example, 1 kilometer is 1000 times larger than 1 meter. This might sound trivial, but not all units have this property. This also means that it's easy to attach prefixes for smaller or bigger values. So instead of saying you walked 1000 meters, you can just use the prefix kilo and say you walked 1 kilometer. And if you're measuring some cells in biology, instead of saying that the cell is 0.00001 meter, you can just say it's 1 micrometer. This is especially nice for very big and small values. In this video we have discussed SI units so far, but there are many other systems in use around the world. But the SI units are the most widely used. Earlier most people used imperial units, which are units derived from everyday objects like a foot, a pint, a stone. Such systems used to make good sense because the SI units of today have a quite arbitrary definition. So before globalization, it was hard to define such a unit globally. On the other hand, almost everyone has feet, and thus everyone could at least get an approximate definition of the unit without too much hassle. But the imperial system doesn't have the same base 10 property like the metric system, making it more confusing. As an example, 1 yard is 3 feet and 1 gallon is 128 ounces. This makes conversions less trivial. Luckily, all countries use metric units today except the US, Myanmar, and Liberia. Don't ask me why they still use imperial units. It should be clear now that units are essential to get physical meaning out of numbers. Furthermore, we have seen that the SI system of how a few basic units can lay the foundation for a large system of units, and how we have briefly mentioned that we don't have only scalars but also vector units, which additionally have a direction. Additionally, checking units can help verifying the correctness of answers using dimensional analysis. We have discussed how in our modern world the metric units are a very convenient unit to use. And with that, let's finish the video. And as always, please like, comment and subscribe for more. Stay tuned.